Thanks for tuning in. Today we're going to solve quadratic equations using a couple other methods. Our last video we solved quadratic equations using Desmos for a graphing feature. Today we're going to talk about how to do that with roots and by looking at factoring. Take a quick look at these, do a few examples together, and again, let me know if you have any questions or need to see any further examples at the end of this video. As I said, we're going to start off by looking at solving quadratic equations by the roots method. This method will be reserved for when our b value is actually equal to 0. And that's the only time you're going to find this will work. So let me just throw a question up here and we'll go ahead and get started. So take, for example, as I said, we're going to do 2 or 3 of these using each method. Slowly work our way up in complexity to give you guys plenty of examples to look at. So let's consider x squared minus 100 equals 0. A lot of times I'll ask students just right out the gate, what would be the first thing you guys would do to solve this? Now, looking at the problem, it doesn't seem too difficult, and the first thing I want you to point out or to notice is that, again, when you typically look at a quadratic equation, it is in this form, if it's in its standard form. And in this particular instance, you'll notice that that b value in this case is equal to 0. That tends to make things a whole lot easier for us, and so that we can quickly arrive at an answer. So we've got x squared minus 100 equals 0. Again, this is what I consider the roots method. What we'll simply do is we'll add 100 to both sides. That leaves us with x squared equals 100. And of course, we want to get rid of the squared term, so we'll take the square root of both sides. And we'll get x is equal to plus or minus 10. And those are our two values. And of course, we can quickly verify that. If you want to head over to Desmos and graph that, you'll notice that your quadratic function does cross the x-axis at plus or minus 10. And not only that, of course, this is a quadratic whose axis of symmetry is nothing more than the y-axis. So again, we're going to take a look at a few of these. Let's take a look at another one real fast. B. Let's change it up a little bit. 5 minus x squared is equal to 0. So again, we'll do the same method as before. We're going to solve this thing for x. We'll take the 5, we'll move it to the other side. You got positive 5, we're going to subtract 5 from each side. Negative x is equal to, negative x squared is equal to negative 5. We want to get rid of this negative right there, and of course we'll just multiply both sides by negative 1 or divide both sides by negative 1. You get to pick your poison on that. So we have x squared is equal to 5. And then we'll take the square root of both sides. And x is equal to plus or minus the square root of 5. And of course, this being a Math 2 class, what this video is geared towards, we want to leave our answer in simplest radical form. And then we'll move on to our next problem from there. One more just to make it slightly more difficult, just to take a look at one last example before we move on to factoring. B. This will be C. (3x squared minus 75 is equal to 0. And again, if you want to pause the video for a minute, just work through the problem yourself, make sure you get the correct answer worked out. And then you can verify that with Desmos. That's the beauty of using Desmos. As long as you have a real number solution, you can always get your answer that way. But for this particular problem, I'm going to go ahead and move the 75 to the right-hand side of the equation to have 3x squared is equal to 75. Divide both sides by 3. And that's going to leave me with x squared is equal to 25. And of course, we're going to take the square root of both sides, just like we've done in every other problem. And we have x is equal to plus or minus 5. And there we have our solution for this one. Now, before we move into our second method, I want to point out something for you viewers real fast, particularly about the first example that we talked about in answer choice A. Some of you may have noticed this x squared minus 100 equals 0. You may have noticed that, that is, looking back at our previous units when we were just factoring, you may have noticed really quickly that that is actually a difference of two squares. So some of you may choose to actually solve this guy by factoring. Now, you wouldn't have the same benefit with B. However, pulling out of GCF and C, you could have solved that one by factoring as well. And of course, we realize that that thing would factor to x plus 10, x minus 10. And then we would set each individual piece equal to 0 and solve it, which is where we're going to do and where we're heading next with the second part of this video, and that's actually solving quadratics by factoring. Now, this is going to give you more practice with factoring, and what we want to do is start off by looking at just an equation that's already in factored form. So for our first example, let's take a look at something, again, it's already been factored, so we don't have to worry about factoring the actual quadratic. It's already broken down into binomial terms. What we're going to use here is we're going to use what's called the zero product property. Now, the zero product property is something very simple that you learn to use in elementary grades, and it just has to do with the fact that if I multiply any two values together and I get 0, that means one or both of them have to be equal to 0. So what I'm going to do then is, using that zero product property, I'm going to take each piece of this quadratic, each binomial, and I'll set each one equal to 0. And then we're going to solve each individual linear equation. So for the first one, of course, we would subtract 3. And then we'll divide both sides by 2. And we get m is equal to negative 3 over 2. For the second one, there again, subtract 3 and divide by 4. And we have m is equal to negative 3/4, and thereby giving us our two solutions for this quadratic equation. Again, the key here with this problem is, I just want you guys to see that what's going on is this is how we're going to approach all of our problems. But the first step is going to be to get these quadratic factors, and of course, these binomial factors from our quadratic, and that's what makes this method solved by factoring. Now, this is great as long as our quadratic function is factorable. If it's not factorable, then we're going to have to use one of our other methods that we're going to learn about, or, again, revert back to Desmos, provided it has a real number solution. So, again, let's take a look at a few examples before we end the video today, just to make sure we have multiple tiers of examples to work with. So our first one, let's take a look at x squared minus 11x plus 19, and this guy we're going to set equal to negative 5. And from our previous video that we did on solving using Desmos, I said one of the first things that we've always got to keep in mind as we approach this, the technique that we're going to use time after time after time, is we want to set this thing equal to 0. So that means I've got to get everything on one side, and usually for whatever reason we choose to put everything on the left and make it equal to 0. So to do that, of course, I've got to get this negative 5 over to the other side, and we'll do that by adding 5 to both sides. So when I do that, of course, I've got x squared minus 11x, and we'll add the 5 to the 19 to get plus 24 is equal to 0. And of course, eventually I am going to do a video just on factoring, because I do factor a little bit different when I have a leading coefficient that's something other than 1. But in this case, it's sort of standard run-of-the-mill. We've got a minus plus situation, so we know that when we factor this thing down into its two binomial factors, that it's going to be two negative values in there, two negative factors, because our two negatives will multiply to give us a positive and then add together to get a negative. So we want the factors of 24 that will add to give us a negative 11. So if you need to, you can, somewhere over to the side here, write down all your factors of 24, and then think about which ones will give us a sum of -11. Of course, you can list them all out if you need to. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And of course, they both have to be negative. And then we just think about which one of those will actually give us a sum of -11. And of course, this is the winner chicken dinner. -3 and -8 are the values that I want to substitute in there, because those will add together to give me 11. Now I'm going to use that zero product property that I mentioned just before, set each one of those guys equal to 0. Add 3 to both sides, x equals 3, x equals 8. And again, for the 1000th time on the video, you could always go take this thing, graph it in Desmos, and it will verify. You will see your quadratic equation crossing the x-axis at 3 and 8. So you can check yourself that way. So let's move on. Let's take a look at a quadratic and an instance where, you know, that leading coefficient is not 1, and just walk ourselves through it for our last example, and we'll call it a wrap on this video. So here we go. C. Got 3x squared is equal to 16x plus 12. And again, you see that a couple things as we move into this example. It's not equal to 0, so that's going to be our first thing that we need to deal with. And, you know, what I have a tendency to do is, like I said before, I'm probably going to just take everything and all this jazz that's right here, I'm going to move it over to the other side of that equation. So there goes mine. Got a little bit of a delay going on with my pens there. So I'm going to subtract my 16x from both sides and move it over here to this side. So I have 3x squared minus 16x is equal to 12. And then for my last step, I am going to subtract 12 from both sides to get it to the other side. And then I've got the entire quadratic on one side, and it is equal to 0. And now we'll proceed with factoring this thing. Now, as I said, I employ some different methods for factoring. And, you know, if you've never sat in one of my class or never watched a video that I've ever done on factoring, this might seem a bit confusing at first. I'm just going to ask you to stay with me, and, you know, a little bit later I'll post a video on how I factor. I attribute the way that I factor these quadratics with a leading coefficient other than 3 or other than 1. I attribute that to a mathematician that I worked with years ago. Her name's Sandy Day. Wonderful teacher. She taught me a really quick way to factor, and I've just used it ever since. But we'll begin with the traditional AC method, which has me multiply the A value and the C value together. That gives me a -36. So again, I want the factors of -36 that add to give you -16. So you could go through your list of factors of 36, but for time's sake, we're just going to go ahead and write it down. That's -18 times +2. And again, you want the product to be -36. And you want the sum to be -16. That's where I get those numbers from. So again, employing this method of factoring that I like to use, I'm going to put down my 2 parentheses equal to 0. I'll write my 3x twice. And then I'll put my 2 factors in. Doesn't matter where you put them. The 18 can come first, or the 2, whichever. You pick your preference. And then I'll take a look at my factors. I see that 1 can be simplified, so that's what I'm going to do next. I'll simplify that out because that 3 shouldn't be there anyway. Again, it's a little trick. So I've got, for my first factor, x minus 6. My second binomial factor, 3x plus 2. Set that guy equal to 0. And again, each term gets set equal to 0 to solve. So we've got x equals 6. Subtract 2 from both sides. 3x is equal to -2. X is going to be equal to -2/3 for my second 0. So again, there's you some examples of solving quadratics by factoring and solving quadratics using the roots method. Let me know what you think of the video. If you have any questions, again, please leave me a comment or send me something on Google Classroom. Thanks so much, guys.